Okay, good afternoon, everyone. Thank you very much for having me again on this session. As I mentioned in my previous session, my role is more as part of the Intergovernmental Oceanography Commission. Sorry, I lost it for a while. But now, which is my role, basically form the science sector in UNESCO. So in UNESCO, we have programs called VISUS, or Visual Inspection for Defining Upgrading Strategy, in which that we focuses more on school safety. And this is more of a science-based assessment methodology for school safety. So as before, we always worked based on a global framework. So we follow the global framework of the SDG, in which that in SDG 4, basically, we are concerned about the quality of education. But in target number 25, it is specifically mentioned about safe school. We, of course, also follows the Sendai framework for disaster risk reductions. And but in more details, we focus on the comprehensive school safety framework. And that's where we actually develop our activity. Another framework which is very important is the from the Global Alliance of our Disaster Risk Reductions and Resilience for in the education sector, where there is a worldwide initiative for safe schools, and this initiative has been signed by more than 35 countries who actually agrees in implementing the initiative for safe school. And one of the most important is that of this initiative that in 2030, every school, old and new, is a safe school. And what we meant by safe schools is that every new school that is built, it has to be based on a safe sites, and it has to implement disaster resilient design and construction. And all schools that has been built, it has to be assessed and to implement prioritization in terms of making sure it is safe, either through retrofitting or replacement. So, as I mentioned, we work basically on the framework of the comprehensive school safety, where we have 4 goals, which basically for student and staff protections, to safeguard educational investment, to ensure that educational will be continued even after disasters, and also to promote the culture of safety and resilience. And the comprehensive school safety have 3 pillars. The pillar 1 is basically looking into the safe learning facilities. Pillar 2 look into the school disaster management, and pillar 3 look into disaster risk and resilience education. We have developed a kind of assessment suites, which looking from different steps. The first step is basically more of a crowd sourcing in terms of getting information about school and how is the schools in terms of safetiness from the point of view of the students and teachers. The second is a school-based self-assessment, in which tools that schools can actually do their own assessment based on pillar 1, 2, and 3. And the third tools is the VISUS, which is basically a more detailed inspection of school facilities, which have this science-based approach. So I did mention this. The safety goals is basically make sure that the safety of the children, teachers, and workers in schools. There is a continuity of education, as well as to reduce the loss of investment. In the 3 pillars, VISUS is basically looking only on pillar 1, which is making sure that the learning facilities are safe for children, teachers, and education workers. And we look into the physical environment. So we look at the site, we look at the buildings, we look at the facilities, as well as the courtyards in the schools. The concern with we started actually developing this methodology is looking into the concern from the decision makers. So there are a number of questions being raised by decision makers, like what is the actual safety situations of the schools? Because many schools has been built for many years, where at that time disaster risk reduction is not yet an issue, and then so they need to look into the situation map of the school safety and which schools needs to be prioritized. If in an area there are hundreds of schools, then they need to be able to prioritize which schools need to be prioritized in terms of enhancing or strengthening the safety. And we have to have a reason why and what kind of intervention is necessary, how much it will cost, how many interventions is feasible, how many we should communicate it, the risk to the community. So these are a lot of questions that was raised by the decision makers, in which basically becomes the background of the methodology that we developed. And we started in developing this methodology by looking into the triage mechanism. As you might know, during medical support in disasters, they use the simple triage system to help in rapid treatment. So they look into, they categorize the victims into different category. For example, the one which is need immediate treatment, the one which is need not immediate treatment, the one that can be treated actually on site, and so forth. So based on this concept, we also do the analogy on building. So we did a triage for safety upgrading in terms of using the pragmatic characterization and evaluations. We look at the building, and then we identify what intervention is needed and what would be the convenience for prioritizing. So this is a kind of an analogy of how actually business works. There are two different problems in buildings. If you are building single buildings, basically what you need to do is to make sure that the building follows the building codes, follows the regulations, follows the standards for earthquake resistance, for flood, and so forth. And basically, if you are building a new building, it is more of a risk control. You are controlling that disaster happens when the hazard strikes. Well, for existing buildings, the difference is that we are now talking about a large number of buildings. There are already existing hundreds of existing school buildings, and this is where the assessment is needed, and we need to do the prioritized intervention, and this is what we considered as part of the risk reduction. So I'll just skip this one. It's basically in terms of looking into an area where there are hundreds of schools. It would be difficult for the decision makers in terms of how to manage the assessment in defining cost-effective safety upgrading between cost and benefit. This is also similar. So basically, in doing assessment, if you are talking countrywide, like for example in Indonesia, we have about 240,000 schools throughout the country. So then, what would be the preliminary assessments we needed? What kind of investment, and what would be the balance between the investment and the safety improvements? And also the issues in terms of upgrading school safety. It is an interdisciplinary problems. So it is not only looking into disaster risk reductions and disaster management. What is the safety goals? What are the lead times? What are the policy? But it also includes technical knowledge. You have to have the science and the knowledge, earthquake engineering, the knowledge of flood, fire, cyclones, and so forth, as well as the social and economy. So the solutions need to address different aspects, not only disaster risk reduction, but also looking into the science as well as the social economy. And we cannot, when we talk about school safety, we cannot only talk safety from one hazard. We need to talk it from multi-hazard. So it might be safe from earthquake, but will it also be safe from floods? So we need to be able to address school safety looking from the multi-hazards. And basically, when we talk about safety, that it should be no victims and no injuries as a consequence of the threat, and it should look into all different aspects of the safety, especially in schools. So we did it in a more of an integrated approach. We divided into 4 of the life philosophy, which is earth, wind, fire, and water. So on earth, we basically look into earthquake and landslides. On wind, we look into the windstorm. On flood, we look on water, we look at flood and tsunamis. And on fire, of course, we look on fire, but whether it is fire which is because of the schools, as well as fire because of the surrounding. For example, if it is part of the forest fire. And in addition, we also look into how the school safety in terms for the ordinary use. It is basically the same. So we need, what we do is, so this is basically the earthquakes, wind, flood, and others. So what we did is basically we try to learn from the experience. We need to identify what we need to evaluate, what are the main issues, and this is specific all for the type of hazard. So in terms for earthquake, we look into the seismic safety, what to be evaluated, and what are the main issues in terms of wind, in terms of flood, in terms of. So we look and basically we look learning from the experience. We identify, this is, for example, building from the same areas. One building collapsed totally, and the other buildings only have a minor damage. So what is happening here? What are the science behind this? What are the construction methodologies being used? So we learn from experience, and we look not only in different one countries, but we also look into from different countries. The previous picture is basically what happens in Italy. This is what happens in Indonesia. There are different construction methods, different building materials, and so forth. So we need to identify all of this before we do the assessment. So based on that experience, we collected all the experience from the different hazards, from the different countries, and then we identify specifically what is the issues, looking from the scientific aspect. And then we start to develop how are we going to do the assessment. So basically, this is another analogy. However, what we are looking in terms of school safety is looking from the location or the site, looking from the structure globally, a school as a complex, as well as locally if the schools have different buildings. We also look into the non-structural elements and functionals. And this assessment basically providing reports of the different school buildings, looking at this safety issues of the 5 aspects, including structure, global, and local. There are different level of knowledge which is needed for the assessment. Of course, the simplest one is only doing the desk analysis based on the available documentation. And the next step is basically data mining, collecting data through questionnaires, form, and checklists. And what FISUS do is, in addition to the data analysis on collection of data, we do actual visual inspections by training surveyors to do a kind of a pragmatic assessment using the triage methodology, as well as using the elements of decision for making support. Once this FISUS is the visual inspection has been done, then we can actually prioritize in terms of which schools would need detailed data acquisitions, basically, which would also lead into the more of technical assessment, how the retrofitting or reconstructions needs to be made in terms of construction as well as design. And the visual assessment, we put it into three aspects. One is the structural response. So we look into the buildings in terms of its structural resistance, and based on the structural resistance as well as the seismic actions, we simplified the models into an algorithm that will then identify the structural performance class of the buildings. The second aspect that we also see is the weakness and the intervention needed, which is more or less based on this visual methodology, in which that the recommendations we will provide through these rows of wiring or intervention needed. So whether there is no retrofitting is needed, which is level 0, or retrofitting is needed to avoid a difficult situation for safety, or retrofitting is needed to avoid heavy consequences of safety. So this is also based on the visual inspections activity. And the third one is the global safety indicators, which we provide global judgment on the safety of the school facility in terms of whether the site is suitable. If the site is not suitable, then they didn't receive any stars. But if the site is suitable, then they have 1 star. If the site is suitable and the stability of the building is strong, then they will receive 2 stars. If the buildings can actually save people, they receive 5 stars. And the 4 star and 5 stars actually related to the continuity of education. The 4 stars is that the schools can resume its operation rapidly, or the 5 stars saying that the schools can immediately start after disasters happen. We developed this visual assessment using, and we developed a kind of a prototype for a tablet-based survey, which is being used by the surveyors. And this is still in the prototype as well as in the development phase. And it covers 3 steps. So it started with identifying what important information is needed for evaluation, and this is then translated into what is needed in the survey to collect the information, important information. For this, we developed the survey tools, survey forms, both paper-based and app-based. And then we developed the evaluation tools in terms of, based on the information collected, how are we going to evaluate this? And for this, we use the logical tree as well as develop the algorithm in terms for the evaluation. And then based on this, we identify how actually this information will be presented for decision making, in which that we then develop the reporting format. This is an example of the reporting format. There is a collective report, and so the collective report will provide information about all schools that has been surveyed, the identifications, the description of the schools, the status of the schools, the multi-hazard assessment indicators, suggested actions, as well as resource needed for the suggested action. In addition, there are also reports for individual schools or individual buildings. I mean, so each one school might have, for example, 3 or 4 buildings. So there is also an assessment that will be given through the individual buildings using the same criteria, the status, the multi-hazard assessment indicators, as well as suggested action. This is just an example of how actually a number of schools being reported, and based on this, decision makers can easily see which schools needs to be prioritized in terms of action. So FISUS is also a monitoring tool. So when we first do the assessment, which is the current situation, that will be the baseline. And then after the intervention, we will see the result or the post of intervention and what progress has it been made. So it can be also become monitoring strategy. The next few slides is basically illustrating how this will help the decision makers. So through the FISUS, we can actually provide several kind of decision-making strategies. On this slide, looking into the school population compared to the multi-hazard stars, we would like to start with schools that is below 3. So, for example, if you look at school S to 7s, it has only 0 stars, but the population about 1,600. So the decision maker might want to prioritize on that particular school. We can also compare this based on the budget allocations, comparing into the individuals and number of population as well as the hazard stars, as well as making decision in terms of prioritizing strategies. So if you have an allocated budget of 1,000, these are the number of schools that you can do in terms of to maximize the number of people based on the budget, or this is the number of schools that you can do to maximize the number of schools based on budget, or to prioritize the schools with the lowest stars and the number of people. And if you increase the budget, then you can also get an illustration of how many additional schools or people that can be assisted in terms of school safety. So that's basically what we can share. This methodology has been used in different countries. We started in Italy, and then we moved in Indonesia, in Laos, in Haiti, in Peru. And this year we are now working in Mozambique in terms of adapting this methodology. And basically we also work with the Ministry of Education.